Welcome to video 9.3. Today we're going to be talking about factoring, specifically the difference of two perfect squares, or D2PS. So what are the methods of factoring? Just like we've done every day and we will continue to do, we're going to list them out. So I need you to copy this down and write them again. The first one is greatest common factor, or GCF. The second one is grouping. The third one is difference of two perfect squares, or D2PS. And that's the one we're going to be focusing on in this video. And the last one is trinomial factoring. Now remember, I want you to write this out fully, not just GCF. I want you to know what it stands for. So you should be writing greatest common factor. Okay, so let's do a recall. Simplify the following. X plus 2 times x minus 2. Well, if we were to simplify this, I would say we'd probably do either double distribution or area model. I'm going to do area model. So off to the side over here, I've written my box with my x plus 2 and my x minus 2. Now I'm going to fill in each area model. So x times x is going to be x squared. And then 2 times x gives me 2x. And negative 2 times x gives me negative 2x. And then lastly, the 2 times negative 2 gives me negative 4 in that last spot there. So then I combine like terms, which usually show up on diagonals, and I can see them on the diagonal here. But something important happens when I combine these, the 2x and the negative 2x, they become 0. So I'm left with x squared minus 4. So this is a special case where these terms in the middle cancel each other out, and we're left with the x squared minus 4. These pairs of factors are conjugates of each other. And that's a word that you need to write down, conjugates. That's when we have the same term here, the x and the 2, but there's different signs in between them, the positive and the negative. So how does this help us with D2PS? So how do we factor? Step 1 is to always check for a GCF. Then the next step will be to look to find out if we have a difference of two perfect squares, D2PS factoring. D means that we must have subtraction, and that is where the word difference comes from in the D2PS. So it must be subtraction. 2 means that we can only have two terms in the expression, so we're looking for a binomial. And the PS means that the terms must be perfect squares, which is why you see Vip's list to the right-hand side. We'll need to check to see if we have a perfect square. So let's fill out this Vip's list, very important perfect squares. So I've listed them out for you on the right here. And remember, we can get these by going to y equals and putting x squared in the equation and going to the table. Okay, so how to write the final factored answer? So if the expression has a GCF, you need to divide out and leave the GCF outside of the parentheses in your final answer. Then, after the GCF is divided out, or if there was no GCF, the remaining expression in parentheses will be broken down into parts using the following setup. Create two sets of parentheses with two different operation signs in the middle of the parentheses. One set of the parentheses with a plus sign, the other with a minus sign. Then you will take the square root of both terms in the expression. Then fill in the square roots of the terms in the parentheses in the correct positions before and after the operation sign. Your answer will always represent a conjugate pair. So that's why that was important. Okay, let's look at one example together. Okay, so the directions here say that for numbers 1 through 9, factor each completely. And there is one that cannot be factored. So for that one, you're going to just write not factorable. So let's look at the first one, y squared minus 16. Well, first we say, is there a GCF? And I don't see anything common in either one, so there is no GCF. The next thing I'm going to look at is it a difference? And I see, yes, it's a difference because of the subtraction sign. Of 2, yes, it's a binomial, two terms. Perfect squares, y squared, that is a perfect square, and 16, that is also a perfect square. So I can take the square root of each, and remember that the steps were to open two sets of parentheses, so I started with that. Then one gets a plus and one gets a minus. Then I look at y squared, the square root of that is y, so I put that first, and then the square root of 16 is 4. So I put that second. Nothing can be factored any more than that. We just have to make sure, and there isn't, so this is our final answer. Okay, we'll do more tomorrow. Have a good night.